Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
As the lead ML engineer for your company, you are responsible for building ML models to digitize scanned customer forms. You have developed a TensorFlow model that converts the scanned images into text and stores them in cloud storage. You need to use your ML model on the aggregated data collected at the end of each day with minimal manual intervention. What should you do? The options are: Option A, use the batch prediction functionality of AI platform. Option B, create a serving pipeline in Compute Engine for prediction. Option C, use cloud functions for prediction each time a new data point is ingested. Option D, deploy the model on AI platform and create a version of it for online inference.
To arrive at the correct answer, we focus on the keywords: TensorFlow model, cloud storage, aggregated data collected at the end of each day, minimal manual intervention.
The correct answer is Option A, use the batch prediction functionality of AI platform.
Why is this correct? AI platform batch prediction is designed for asynchronous inference on large datasets from cloud storage. It perfectly fits the requirement to process daily aggregated data with minimal manual intervention. Why are the others incorrect? B. Building a custom serving pipeline in Compute Engine involves significant operational overhead and infrastructure management, violating the requirement for minimal manual intervention. C. Cloud functions trigger real-time predictions for individual data points upon ingestion, contradicting the requirement to process aggregated data in a batch at the end of each day. D. Online inference is optimized for real-time, low-latency predictions on individual requests. It is inefficient and inappropriate for processing large volumes of daily aggregated data.
You recently joined an enterprise-scale company that has thousands of datasets. You know that there are accurate descriptions for each table in BigQuery, and you are searching for the proper BigQuery table to use for a model you are building on AI platform. How should you find the data that you need? The options are: Option A, use data catalog to search the BigQuery datasets by using keywords in the table description. Option B, tag each of your model and version resources on AI platform with the name of the BigQuery table that was used for training. Option C, maintain a lookup table in BigQuery that maps the table descriptions to the table ID. Query the lookup table to find the correct table ID for the data that you need. Option D, execute a query in BigQuery to retrieve all the existing table names in your project using the information_schema metadata tables that are native to BigQuery. Use the result to find the table that you need.
To arrive at the correct answer, we focus on the keywords: thousands of datasets, accurate descriptions for each table in BigQuery, searching for the proper BigQuery table.
The correct answer is Option A, use data catalog to search the BigQuery datasets by using keywords in the table description.
Why is this correct? A. Google Cloud Data Catalog is a fully managed, scalable metadata management service designed to quickly discover, manage, and understand data. It allows searching BigQuery datasets efficiently using keywords in table descriptions. Why are the others incorrect? B. Tagging models only helps with tracking lineage after a model is trained. It does not solve the problem of discovering or searching for the right data source. C. Creating and maintaining a manual lookup table is unscalable, error-prone, and unnecessary, as Data Catalog already provides built-in, managed metadata search capabilities. D. Information_schema metadata tables provide structural metadata like table names but do not store or allow searching by user-defined table descriptions, which is required here.
Your team is building a convolutional neural network, CNN-based architecture from scratch. The preliminary experiments running on your on-premises CPU-only infrastructure were encouraging, but have slow convergence. You have been asked to speed up model training to reduce time to market. You want to experiment with virtual machines, VMs, on Google Cloud to leverage more powerful hardware. Your code does not include any manual device placement and has not been wrapped in estimator model-level abstraction. Which environment should you train your model on? The options are Option A, AVM on compute engine and 1 TPU with all dependencies installed manually. Option B, AVM on compute engine and 8 GPUs with all dependencies installed manually. Option C, a deep learning VM with an N1 standard 2 machine and 1 GPU with all libraries pre-installed. Option D, a deep learning VM with more powerful CPU E2 HiCP 16 machines with all libraries pre-installed.
To arrive at the correct answer, we focus on the keywords: convolutional neural network, CNN, based architecture from scratch, speed up model training, virtual machines, VMs, on Google Cloud. Code does not include any manual device placement and has not been wrapped in estimator model level abstraction.
The correct answer is option C, a deep learning VM with an N1 standard 2 machine and 1 GPU with all libraries pre-installed.
Why is this correct? C. A deep learning VM with a single GPU is ideal because CNNs benefit significantly from GPU acceleration. Without manual device placement or estimator abstractions, the code cannot automatically utilize multiple GPUs or TPUs. Pre-installed libraries save setup time. Why are the others incorrect? A. TPUs require specific code modifications, such as using the estimator API or TPU strategy, which the current code lacks. Manual installation of dependencies also slows down experimentation. B. Training on multiple GPUs requires code changes for distributed training, such as manual device placement or distribution strategies. Without them, the code will only utilize one GPU. D. While a more powerful CPU might offer a slight improvement, it will not provide the significant speedup needed for CNNs compared to utilizing a GPU.
You work for a magazine distributor and need to build a model that predicts which customers will renew their subscriptions for the upcoming year. Using your company's historical data as your training set, you created a TensorFlow model and deployed it to AI platform. You need to determine which customer attribute has the most predictive power for each prediction served by the model. What should you do? The options are Option A, use AI platform notebooks to perform a lasso regression analysis on your model, which will eliminate features that do not provide a strong signal. Option B, stream prediction results to BigQuery. Use BigQuery's core X1, X2 function to calculate the Pearson correlation coefficient between each feature and the target variable. Option C, use the AI explanations feature on AI platform. Submit each prediction request with the explain keyword to retrieve feature attributions using the sampled Shapley method. Option D, use the what if tool in Google Cloud to determine how your model will perform when individual features are excluded. Rank the feature importance in order of those that caused the most significant performance drop when removed from the model.
To arrive at the correct answer, we focus on the keywords: TensorFlow model, deployed it to AI platform, determine which customer attribute has the most predictive power for each prediction.
The correct answer is option C, use the AI explanations feature on AI platform. Submit each prediction request with the explain keyword to retrieve feature attributions using the sampled Shapley method.
Why is this correct? C. AI explanations integrates with AI platform to provide feature attributions, using sampled Shapley, for each prediction. This natively identifies which attributes most strongly influence the model's specific output for each individual request. Why are the others incorrect? A. Lasso regression is a different model type used for feature selection during training. It cannot be applied to explain predictions for an already trained and deployed TensorFlow model. B. Pearson correlation only measures global linear relationships between features and targets across a dataset. It does not provide per prediction feature importance for complex models. D. The What-If tool is an interactive visual interface for exploring model behavior. It is not designed to automatically retrieve feature attributions for each individual prediction request served by the model in production.
Your company manages an application that aggregates news articles from many different online sources and sends them to users. You need to build a recommendation model that will suggest articles to readers that are similar to the articles they are currently reading. Which approach should you use? The options are: Option A, create a collaborative filtering system that recommends articles to a user based on the user's past behavior. Option B, encode all articles into vectors using Word2Vec, and build a model that returns articles based on vector similarity. Option C, build a logistic regression model for each user that predicts whether an article should be recommended to a user. Option D, manually label a few hundred articles, and then train an SVM classifier based on the manually classified articles that categorizes additional articles into their respective categories.
To arrive at the correct answer, we focus on the keywords, recommendation model, suggest articles, similar to the articles they are currently reading.
The correct answer is option B, encode all articles into vectors using Word2Vec, and build a model that returns articles based on vector similarity.
Why is this correct? B is correct because converting articles to vectors and using vector similarity is a standard content-based filtering approach that effectively identifies items similar to what the user is currently reading. Why are the others incorrect? A is incorrect because collaborative filtering relies on past user behavior across users, rather than the content similarity of the articles themselves as required by the prompt. C is incorrect because training an individual logistic regression model per user is highly unscalable and does not inherently leverage content similarity between articles. D is incorrect because manually labeling data and training a classifier categorizes articles but doesn't directly solve the problem of recommending articles based on their similarity to a currently read article.
You are building a linear model with over 100 input features, all with values between -1 and 1. You suspect that many features are non-informative. You want to remove the non-informative features from your model while keeping the informative ones in their original form. Which technique should you use? The options are: Option A, use Principal Component Analysis, PCA, to eliminate the least informative features. Option B, use L1 regularization to reduce the coefficients of uninformative features to 0. Option C, after building your model, use Shapley values to determine which features are the most informative. Option D, use an iterative dropout technique to identify which features do not degrade the model when removed.
To arrive at the correct answer, we focus on the keywords, linear model, remove the non-informative features, keeping the informative ones in their original form.
The correct answer is option B, use L1 regularization to reduce the coefficients of uninformative features to 0.
Why is this correct? B. L1 regularization, lasso, adds a penalty equal to the absolute magnitude of coefficients, which forces coefficients of non-informative features to exactly 0. This performs direct feature selection while preserving the selected informative features in their original form. Why are the others incorrect? A. PCA transforms the input data into new principal components that are linear combinations of the original features, which violates the requirement to keep informative features in their original form. C. Shapley values are computationally expensive to calculate for many features and are primarily used for post-training interpretation rather than direct, efficient feature selection during model training. Why are the others incorrect? D. Using iterative dropout to evaluate feature removal is a computationally inefficient and non-standard heuristic for linear models compared to the built-in, mathematical sparsity provided by L1 regularization.
Your company manages a video sharing website where users can watch and upload videos. You need to create an ML model to predict which newly uploaded videos will be the most popular so that those videos can be prioritized on your company's website. Which result should you use to determine whether the model is successful? The options are: Option A, the model predicts videos is popular if the user who uploads them has over 10,000 likes. Option B, the model predicts 97.5% of the most popular clickbait videos measured by number of clicks. Option C, the model predicts 95% of the most popular videos measured by watch time within 30 days of being uploaded. Option D, the Pearson correlation coefficient between the log-transformed number of views after 7 days and 30 days after publication is equal to 0.
To arrive at the correct answer, we focus on the keywords: predict which newly uploaded videos will be the most popular, determine whether the model is successful.
The correct answer is option C. The model predicts 95% of the most popular videos measured by watch time within 30 days of being uploaded.
Why is this correct? C. Watch time over a 30-day period is a robust, direct measure of true video popularity and sustained user engagement, making it an excellent metric for evaluating the model's success. Why are the others incorrect? A. This uses a simple heuristic based on the creator's history rather than an evaluation metric that measures how successfully the model predicts the actual popularity of new videos. B. Optimizing for clicks measures clickbait effectiveness rather than genuine popularity or user satisfaction, which could ultimately harm the website's user experience. D. A correlation coefficient of 0 indicates no linear relationship between short-term and long-term views, which does not demonstrate that the model successfully predicts video popularity.
Your data science team needs to rapidly experiment with various features, model architectures, and hyperparameters. They need to track the accuracy metrics for various experiments and use an API to query the metrics over time. What should they use to track and report their experiments while minimizing manual effort? The options are: Option A, use Kubeflow pipelines to execute the experiments. Export the metrics file, and query the results using the Kubeflow pipelines API. Option B, use AI platform training to execute the experiments. Write the accuracy metrics to BigQuery, and query the results using the BigQuery API. Option C, use AI platform training to execute the experiments. Write the accuracy metrics to cloud monitoring, and query the results using the monitoring API. Option D, use AI platform notebooks to execute the experiments. Collect the results in a shared Google Sheets file, and query the results using the Google Sheets API.
To arrive at the correct answer, we focus on the keywords: rapidly experiment, track the accuracy metrics, API to query the metrics, minimizing manual effort.
The correct answer is option A. Use Kubeflow pipelines to execute the experiments. Export the metrics file, and query the results using the Kubeflow pipelines API.
Why is this correct? A. Kubeflow pipelines provides native support for tracking ML experiments, parameters, and metrics, and includes an API to query results, effectively minimizing manual effort. Why are the others incorrect? B. Exporting metrics to BigQuery requires writing custom integration code to track experiments, which increases manual effort compared to using specialized ML tracking tools. C. Cloud monitoring is intended for tracking infrastructure and application health, not for logging and comparing ML model experiment metrics and hyperparameters. D. Using Google Sheets is highly manual, error-prone, and lacks the robust features required for efficient, automated ML experiment tracking at scale.
You work for an advertising company and want to understand the effectiveness of your company's latest advertising campaign. You have streamed 500 megabytes of campaign data into BigQuery. You want to query the table, and then manipulate the results of that query with a pandas data frame in an AI platform notebook. What should you do? The options are: Option A, use AI platform notebooks BigQuery Cell Magic to query the data, and ingest the results as a pandas data frame. Option B, export your table as a CSV file from BigQuery to Google Drive, and use the Google Drive API to ingest the file into your notebook instance. Option C, download your table from BigQuery as a local CSV file, and upload it to your AI platform notebook instance. Use pandas.read_CSV to ingest the file as a pandas data frame. Option D. From a bash cell in your AI platform notebook, use the bqextract command to export the table as a CSV file to cloud storage, and then use ctl-cp to copy the data into the notebook. Use pandas.read_CSV to ingest the file as a pandas data frame.
To arrive at the correct answer, we focus on the keywords: BigQuery, query the table, pandas data frame, AI platform notebook.
The correct answer is option A. Use AI platform notebook's BigQuery cell magic to query the data and ingest the results as a pandas data frame.
Why is this correct? A. BigQuery cell magic in AI platform notebooks provides a direct, built-in, and highly efficient way to query BigQuery data and ingest the results directly into a pandas data frame without intermediate storage steps. Why are the others incorrect? B. Exporting to Google Drive adds unnecessary complexity, requires extra API configuration, and involves inefficient intermediate steps when direct notebook integration already exists. C. Downloading locally and manually uploading is a manual, non-reproducible, and highly inefficient process that defeats the purpose of using integrated cloud-based notebooks. D. Using cloud storage as an intermediate staging area via bash commands is overly complex, requires additional steps, and is unnecessary given the native BigQuery cell magic integration.
You are developing a Kubeflow pipeline on Google Kubernetes Engine. The first step in the pipeline is to issue a query against BigQuery. You plan to use the results of that query as the input to the next step in your pipeline. You want to achieve this in the easiest way possible. What should you do? The options are: Option A, use the BigQuery console to execute your query, and then save the query results into a new BigQuery table. Option B, write a Python script that uses the BigQuery API to execute queries against BigQuery. Execute this script as the first step in your Kubeflow pipeline. Option C, use the Kubeflow pipeline's domain-specific language to create a custom component that uses the Python BigQuery client library to execute queries. Option D, locate the Kubeflow pipeline's repository on GitHub. Find the BigQuery query component, copy that component's URL, and use it to load the component into your pipeline. Use the component to execute queries against BigQuery.
To arrive at the correct answer, we focus on the keywords: Kubeflow pipeline, query against BigQuery, easiest way possible.
The correct answer is option D. Locate the Kubeflow pipeline's repository on GitHub. Find the BigQuery query component, copy that component's URL, and use it to load the component into your pipeline. Use the component to execute queries against BigQuery.
Why is this correct? D. Using a pre-built BigQuery component from the official Kubeflow pipelines repository is the easiest approach, as it eliminates the need to write and maintain custom code. Why are the others incorrect? A. Manually executing queries in the console breaks automation and does not integrate the step into the Kubeflow pipeline. B. Writing a custom Python script requires additional coding and maintenance effort compared to leveraging an existing pre-built component. C. Building a custom component from scratch is unnecessary and more complex when an officially supported BigQuery component already exists.
Your team trained and tested a DNN regression model with good results. 6 months after deployment, the model is performing poorly due to a change in the distribution of the input data. How should you address the input differences in production? The options are: Option A, create alerts to monitor for skew and retrain the model. Option B, perform feature selection on the model and retrain the model with fewer features. Option C, retrain the model and select an L2 regularization parameter with a hyperparameter tuning service. Option D, perform feature selection on the model and retrain the model on a monthly basis with fewer features.
To arrive at the correct answer, we focus on the keywords, change in the distribution of the input data, address the input differences.
The correct answer is option A, create alerts to monitor for skew, and retrain the model.
Why is this correct? A. Data skew or drift occurs when the input data distribution changes. The best approach is to monitor for this skew using alerts and retrain the model on the newer data to restore its performance. Why are the others incorrect? B. Feature selection removes features but does not address the underlying issue of the data distribution changing over time. C. L2 regularization helps prevent overfitting on the original training set. It does not resolve issues caused by a changing data distribution in production. D. Feature selection is irrelevant to addressing data drift, and an arbitrary monthly retraining schedule without monitoring may not capture or address specific distribution changes.
You were asked to investigate failures of a production line component based on sensor readings. After receiving the dataset, you discover that less than 1% of the readings are positive examples representing failure incidents. You have tried to train several classification models, but none of them converge. How should you resolve the class imbalance problem? The options are: Option A, use the class distribution to generate 10% positive examples. Option B, use a convolutional neural network with max pooling and softmax activation. Option C, downsample the data with upweighting to create a sample with 10% positive examples. Option D, remove negative examples until the numbers of positive and negative examples are equal.
To arrive at the correct answer, we focus on the keywords, less than 1% of the readings are positive examples, none of them converge, class imbalance problem.
The correct answer is option C, downsample the data with upweighting to create a sample with 10% positive examples.
Why is this correct? C. Downsampling the majority class and upweighting the downsampled examples is the recommended approach for extreme class imbalance. It improves training convergence while preserving the original dataset's mathematical expectations. Why are the others incorrect? A. Generating synthetic positive examples based on the existing class distribution does not effectively add meaningful new information and can introduce noise or cause overfitting. B. Changing the model architecture to a convolutional neural network does not resolve the underlying data issue of severe class imbalance. D. Removing negative examples until both classes are exactly equal severely reduces the dataset size, discarding massive amounts of valuable information and causing poor generalization.
You have developed an AutoML tabular classification model that identifies high-value customers who interact with your organization's website. You plan to deploy the model to a new Vertex AI endpoint that will integrate with your website application. You expect higher traffic to the website during nights and weekends. You need to configure the model endpoint's deployment settings to minimize latency and cost. What should you do? The options are: Option A, configure the model deployment settings to use an N1 standard 32 machine type. Option B, configure the model deployment settings to use an N1 standard 4 machine type. Set the min replica count value to 1 and the max replica count value to 8. Option C, configure the model deployment settings to use an N1 standard 4 machine type and a GPU accelerator. Set the min replica count value to 1 and the max replica count value to 4. Option D, configure the model deployment settings to use an N1 standard 8 machine type and a GPU accelerator.
To arrive at the correct answer, we focus on the keywords, AutoML tabular classification model, higher traffic to the website during nights and weekends, minimize latency and cost.
The correct answer is option B, configure the model deployment settings to use an N1 standard 4 machine type. Set the min replica count value to 1 and the max replica count value to 8.
Why is this correct? B. Autoscaling with min replica count and max replica count handles variable traffic efficiently, minimizing costs during low traffic and latency during high traffic. A standard CPU machine like N1 Standard 4 is cost-effective and sufficient for tabular model inference. Why are the others incorrect? A. Using a single large machine without autoscaling cannot adapt to variable traffic, leading to higher costs during low traffic and potential latency spikes during peak periods. C. GPUs are generally unnecessary and not cost-effective for tabular classification models. Using a GPU significantly increases costs without proportional benefits for this model type. D. This option lacks autoscaling to handle variable traffic and includes an unnecessary GPU accelerator, both of which will significantly increase costs for tabular classification inference.
You work at an organization that maintains a cloud-based communication platform that integrates conventional chat, voice, and video conferencing into one platform. The audio recordings are stored in cloud storage. All recordings have an 8 kHz sample rate and are more than 1 minute long. You need to implement a new feature in the platform that will automatically transcribe voice call recordings into a text for future applications, such as call summarization and sentiment analysis. How should you implement the voice call transcription feature following Google recommended best practices? The options are: Option A, use the original audio sampling rate, and transcribe the audio by using the speech-to-text API with synchronous recognition. Option B, use the original audio sampling rate, and transcribe the audio by using the speech-to-text API with asynchronous recognition. Option C, upsample the audio recordings to 16 kHz, and transcribe the audio by using the speech-to-text API with synchronous recognition. Option D, upsample the audio recordings to 16 kHz, and transcribe the audio by using the speech-to-text API with asynchronous recognition.
To arrive at the correct answer, we focus on the keywords 8 kHz sample rate, more than 1 minute long.
The correct answer is option B, use the original audio sampling rate, and transcribe the audio by using the speech-to-text API with asynchronous recognition.
Why is this correct? B. Asynchronous recognition is required for processing audio longer than 1 minute. Google best practices state you should provide audio at its original sample rate, as upsampling does not improve transcription accuracy. Why are the others incorrect? A. Synchronous recognition is strictly limited to processing audio files of 1 minute or less in duration. C. Synchronous recognition cannot process audio longer than 1 minute. Additionally, upsampling audio from 8 kHz to 16 kHz is not recommended by Google. D. While asynchronous recognition is correct, Google best practices recommend against upsampling audio to 16 kHz before sending it to the API, as it provides no benefit.
You are using Vertex AI and TensorFlow to develop a custom image classification model. You need the model's decisions and the rationale to be understandable to your company's stakeholders. You also want to explore the results to identify any issues or potential biases. What should you do? The options are: Option A, 1. Use TensorFlow to generate and visualize features and statistics. Point 2. Analyze the results together with the standard model evaluation metrics. Option B, 1. Use TensorFlow Profiler to visualize the model execution. Point 2. Analyze the relationship between incorrect predictions and execution bottlenecks. Option C, 1. Use Vertex Explainable AI to generate example-based explanations. Point 2. Visualize the results of sample inputs from the entire dataset together with the standard model evaluation metrics. Option D, 1. Use Vertex Explainable AI to generate feature attributions. Aggregate feature attributions over the entire dataset. Point 2. Analyze the aggregation result together with the standard model evaluation metrics.
To arrive at the correct answer, we focus on the keywords Vertex AI and TensorFlow, image classification model, model's decisions, and the rationale to be understandable. Identify any issues or potential biases.
The correct answer is option D, 1. Use Vertex Explainable AI to generate feature attributions. Aggregate feature attributions over the entire dataset. Point 2. Analyze the aggregation result together with the standard model evaluation metrics.
Why is this correct? D. Vertex Explainable AI provides feature attributions for image models, highlighting which pixels influenced decisions. Aggregating these across the dataset helps identify global issues and potential biases, fulfilling stakeholder requirements for understandable rationale. Why are the others incorrect? A. Generating basic features and statistics does not explain individual model decisions or provide the clear rationale needed by stakeholders to understand predictions and evaluate biases. B. TensorFlow Profiler is a tool used to analyze execution performance and identify hardware bottlenecks. It cannot be used to explain model decisions, rationale, or evaluate biases. Why are the others incorrect? C. While Vertex Explainable AI offers example-based explanations, feature attributions, highlighting specific image regions, are standard and generally more effective for stakeholders evaluating the rationale behind a custom image classification model's specific decisions.